Hi, everybody. Welcome again. Today we are going to learn about the magnetic effect of the electric current. In the last part, we have learned about latest part. We have learned about the uh, heating effect of electric current. Okay, so in this part, we are going to learn about magnetic effect of electric current. Which effect? Magnetic effect. Okay, so, what is magnetic effect? That is what I will explain you now. See, to make that magnetic effect of electric current, there were scientists named Orested. So he worked on it and found out what was happening. So first I will explain you and then show what he done to explain to the common people that the wire conducts electricity, not electricity. It uh, creates an effect of magnetism. So see, first I will explain you by this simple diagram. Okay, when we pass electricity uh, to this wire through the cell, then what happens is that this wire becomes a magnet and acts like a magnet. Means basically it gains magnetism in it. Okay, so it gains some magnetism in it when we pass the electric current through it. Then the Orested observed that this thing, and to explain to other people, uh, he done some experiments and found out best way, the best diagram to show that the wires are the conducting wires. These are always conducting wires are means make creating magnetism there. Okay, so that the diagram shown to the people was, see, I'm drawing. So I will label things first. Okay, this we know it's a battery, this is a plug, or we can say it a switch, and this new thing is a compass. You know, compass, it's used for locating things. So when the plug was off, means the switch was not on, the compass was working perfectly. Okay, and he wrapped around it. Okay, around the compass. Now also the compass was working very nicely. But as soon he started electricity, what happened was that the compass was not showing normal, which are the real north-south directions. It was getting deflected. Okay, so this was observed by the Sir Orested, and then he concluded that with the many discussion of many scientists that when we pass electricity through any conductor, through any conductor, it behaves like a magnet. Okay, and as it is behaving, this wire is behaving like a magnet. So of course, then only it is deflecting the compass. Okay, so this was observed by Sir Orested. Okay, at that time. Now you may ask, how much the it will of course have some power. How much the, like in the heat we learned that it depends upon the length, it depends upon the thickness, it depends upon the nature of the substance. Here also there are two properties. So how much powerful will the magnetic field will be depends upon two things. Okay, so first one is number of coils. Means see, this is a box. Okay, so if you want to make this box uh, a magnetic one. Okay, so you have to pass the current through this wire. Assume this wire you are passing current, then you have to coil it. Okay, so if this number of coils will be more, okay, number of coils will be more. So the more powerful this magnet will be, electromagnet will be. Okay, and if the number of coils are more, you may assume that as the number of coil increases, the length also increases. of this wire, means of this which we are coiling. So length also increases. So you can say number of coils or length, but we cannot say length directly. It's better to say number of coils. Okay. Second one is amount of current. Okay. So more the current you pass through it, the more powerful this electromagnet will be. So if you pass 10 amperes of current, so it will be powerful. If you pass 20 amperes of current, it will be more powerful than the 10 ampere one. So amount of current is also dependent. Okay. So these are the two factors. First one is number of coils and second one is amount of current used. Okay. So this magnet made by this process means made by coiling and passing electric current. So this type of magnets are known as the magnets made by passing made by passing electricity are known as electricity are known as electromagnets. Okay, what do we call them? We call them electromagnets. Okay, and what are the uses of electromagnets? You may ask me. Okay, so I will tell you the uses of electromagnets. Okay, uses. Firstly, in the scrap collection. See, when we sort the scrap, there is a crane here. Then what this crane does, it's an having like this rigid support. So what is this part? Do you know what is this part? It is really a electromagnet. Okay, this one is electromagnet. The coils are there, but they are not properly visible. So visible to us. What is the use of it is, uh, of course, electromagnet also has north and south pole. Yeah. So let's start with first use A. First use A. Okay. So you can on and off the magnetism whenever you want. Okay. So if this person here sitting here wants to on it, so it can press on and then all the scrap will be upside. Okay, so you can on and off it. Control means basically control the electromagnet, correct? Control the electromagnet. Okay, the second thing is that if you are passing the electric current first from right to left, here it's passing means the current is in the direction. So this part here, assume it first it was south and then uh, it is north. If you pass the current from here, I will draw a proper again diagram for it. First you are passing current from here and taking out from here. So if first it was south and it was north, then if you reverse the direction of current, means if you now you are passing current through it. Okay, so now there will be a reverse in direction. Now the south will come here and north will go here. Where this property is used, if we want to not make it like there are two magnets, assume two magnets. This is in hexagonal shape and this is in square shape. So first it was north and it was south. Okay, and this part is south, this part is north. Okay, so now you want to connect this, but after some time you want to remove it. So what can you do? Reverse the directions. So now this part will become south and this part will become north. So this will not connect. So these are the uses by you can means do right to left means until changing the interchanging the poles. Okay, and these are the two major the major advantages that we will be very in very profit because of this advantages, because everything is in our control. So these are the uses of electromagnet. So how is electromagnet made? Okay, how is it made? Yeah, how is it made? So I will tell you how is it made. I have shown you the diagram of the circuit diagram of Orested, but it was for showing that people that the wire conducts conducting wire has a magnetism when electric current is passed. But to make an electromagnet, the simplest way we will make a scribe a electromagnet. So let's start. We will draw a circuit diagram first. I'll show you. Oh, wait. I will draw a bigger diagram. Downside. Okay, here. Yeah, it's a bigger space. Draw a script. Here it's a script. This is a script. Okay, now what they do is wrap the coil around it. Okay, so wrap the coil around it. Then here, as the current flows, then this material, whatever it is made up of, when as the electric current is continuously flowing, it acts as a magnet. Some materials also become permanent magnets, and some materials remain for some time as a magnet. This acts as a permanent magnet, or depending upon the material, it acts. But we can write here is it acts as a magnet directly. Okay, so it acts as a magnet. So this is how the material is used. Then by this method we are having one more profit by for electromagnet, that we can shape it like anything. See, we are normally taking a metal. Okay, take any metal of any shape. I'm drawing an hexagon. It's a hexagon. So the real magnetite means the magnets found on the earth are very irregular shapes. So we will by melting and all that we will make any shape, and then what we will do is plus minus. Simply coil it, and make it magnet. So simply we are making magnets out of any metal. Oh, not any metal, the conducting metals. Okay, so the best metal to make this magnets are alnico. It's not a metal, it's an alloy. So alnico, we can divide it. Alnico, it's an alloy of aluminium, nickel, and cobalt. Okay, so when we pass the electric current through this alnico alloy, so what happens is that this becomes a permanent magnet. Okay, 1 minute. I will draw it. So if the and this property of making permanent magnets also applies on steel. If we pass steel, means not pass, if we pass current through steel also, then also this steel also will become an permanent magnet. And how strong it is, as I told, how much we are coiling it, it depends on it. And the second, how much electric current are we passing through the steel. So if we pass very much of electric current and for more time, then the powerful electro magnet it will be. Okay, and as it is permanent, we can call it magnet also. And the problem with natural magnets is most of them are not so powerful. That like in scrap industry, you have this much magnet and you have a big dump, and this is having many metals. So how to do it with normal metals? But this is very powerful magnet, so it will be very fast and pick up all the metals used in sorting the garbage. Okay, so that's the problem with the natural magnets present on the earth. So we can make it permanent also. So okay, so this was all for today. What we learned was magnetic effect of electric current. Okay, so we learned what is the meaning of it, then how orchestra demonstrated with the local people or not the local for general people. So what the electromagnet depends upon, the power of electromagnet depends upon. Okay, so the power of electromagnets depends upon firstly number of coils, secondly amount of current passed through it. Okay, so magnet is very useful, but the electromagnets are much more useful than them. Okay, so uses. So in scrap collection, uh, it is used, and many more things. Like second, I will tell one more use of it. Second, if you the doctors uses this electromagnets if some small particles of metals have gone in your eyes. Okay, in your eyes, then they remove it with the electromagnet. That electromagnet is not very strong, otherwise the metals will scratch our eyes, but it is a feeble one, but it's useful. Okay, then I told you afterwards, I taught you that how to control the electromagnet means, and there was the plus points of electromagnets, the plus points. So I told what were the plus points. Control the electromagnet passing right to left means alternating currents. If we pass from right side, we can pass from left side also, and according to that the north south pole will change. Okay, then we can change the shape of the electromagnet. This was the third one. We can change the shape of the electromagnet. Like if we melt it directly, then it will be of another shape. And if we pass the electric current and with more number of coils, it will be again a magnet. So no problem with the shape. But the natural with the natural magnets, we cannot do such things. They will completely lose their electro not electromagnetism, their own magnetism. So I told how is an electromagnet made. I have shown you here with this diagrams. And what are the materials used for making electromagnets? These are the materials which are used for making electromagnets. If we use only iron, okay, so, and if we pass the electric current through iron, it will not be a permanent magnet, it will be a temporary magnet. Okay, this is what written in my book. It will be a temporary magnet. Okay, so like our screen is basically made up of what? Iron. And if we do it with iron, if you can do this experiment and see that is this becoming a permanent magnet? I think it will not become a permanent magnet because it's made up of iron, and according to me and according to many books it will become a temporary magnet. And I want to tell you one more thing, that was, see, I will draw a diagram here. With diagrams we can understand very quickly and easily. That's why I'm using this new method of teaching. So see, this are object 1, object 2. Assume it a magnet, assume it a magnet, and assume it a normal metal. So what will be difference in the molecular structure, overall molecular structure of this? See, so here some molecule be here, some 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 here. Like they are not properly placed, like in a row or anything. But here it will be very proper, one above another in a row. Like they are very managed ones, like in a row. They will stand in a row. They are disciplined ones. Okay, so these magnets are disciplined, and this the normal metals are not disciplined. What happens as they are disciplined is the electromagnets. 1 minute. Okay, so see this one. So here they attract. Here some molecules will be there. So that's why they attract some metal here. Okay, so this is a magnet's molecular structure and this is a normal metal. Normal metals molecules go anywhere. They are not in a proper order. They are in proper order, but they are not so in proper order. Not too proper. Okay. So here it's in proper order. So when we pass electricity to this, they became in proper order. Proper order. They come, see, properly. Okay. They come in means I will cut this. So they come in rows and all that. Okay, put a put electricity and flow electricity through the metal. Okay, and as we cannot flow the electricity through the insulator, so that's why they cannot become a magnet. And as the electricity will not flow, then how the molecules and atoms will get aligned. Okay, so that's all for today. I will show you everything in one shot. So this was what we have learned today. If you like this video, you can like this video. Then you can press the like button, you can press the subscribe button if you are liking our videos continuously, and I think you might be liking, and if you're getting information from my videos, you can share to your another friend, as he can also get information about this magnetism and electricity. And I am going to upload many videos in the future, so you can share, subscribe and like to our channel and this video. Thank you.